In this video, I'm going to be examining the Theora texture object. I've copied the files from the Theora texture object to my bitmap texture object here in my source. Uh, these are accessible to the console and scripting engine directly, and let me bring up torsion here so you can see. I'll have it in a different window. Here you can see bitmap texture object sky video as opposed to Theora texture object sky video. So you can see in the code itself for test project no physics, which is the same one we have in Visual Studio. You can see that it's actually being run in game. I have the game itself running in a separate desktop, so it's not going to pop up here. It's not particularly important for the scope of this video to actually see the game running, but here you can see I have a breakpoint. Now, text delegate here is called repeatedly. This is really where the majority of the processing actually occurs. This is where frames are pulled and frames are set, and by actually kind of investigating the mechanisms behind this, we'll be able to see directly how to draw frames directly. So step. Here we have refresh. If you saw from back here, when the text delegate is called, and it is called, like I said, on a loop to supply the texture with video data. When it is refreshed, it goes to right here. What's important in here is that it has a routine in here that defines whether or not it needs a packet. Now, the packet is an asynchronous packet queue. The packet queue basically queues up frames to be rendered and drops frames where necessary. So here you can see frame async state, read next frame, if not frame, do this. Well, essentially this loop here will pull packets for as long as it needs packets, and then it will basically exit the application, and I believe at that point it starts rendering. So let's go ahead and step. Since this is the beginning of the application, I think it validates that it can lock a rectangle. I think this is just locking the texture. I'm not 100% on this. Step. Or you can see within the scope, it declares and reads the frame. It exits a loop if it can't read a frame. Yeah, it's not dependent on the return, I guess. Oh yeah, you know what? Since this is being actively worked upon, I don't think it really worries. I'm sorry, the application isn't really worried about any return data. So do current frame and mlocked rectangle. So here it unlocks. Here you can see overloaded operator. From fast delegate, if you watched other videos, you would see that fast delegate is used for a variety of delegations. Step tell return. Here you can see get texture is invoked. I think the texture is pulled right here. it's important when you're watching the video to make sure you pay attention to this up here so you can see what file we're in. So this is code I had to add. I had to add this to the engine, so it's important to know that I added this. It was because name text targets weren't working appropriately for some reason. So let's step. Execute till return. This is the old code right here, the fuse map. Process shader material in it. So this is just shading whatever it's rendering, I guess. I don't know. So let's step. So let's return. So return. 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 Fast delegate again. Till return. So this has nothing to do with our code. I mean, except for that it's rendering stuff. So you can see refresh actually does a whole lot of processing. Here it's working again. So this does this pretty continuously. Continue. But here, I mean, just watching that, you can kind of get an idea. It just refreshes this. Get a breakpoint here. So the delegate system basically returns the texture. So hopefully here we can exit and see what's actually calling this. GFX texture handle, GFX texture object, get pointer. You can see that it's actually overwriting this. This is part of the GFX text handle class. And I think when you actually register the Theora text object, or in this case our bitmap texture object, it sets the pointer in here. So if I step it, should be get pointer, cast, static cast, yeah, M object. And where M object is. Strong reference base, strong object reference. So that's part of the object reference system. So this is going to return step, step, So here you can see how the texture is actually set. It's in process shader materials, I guess. This is where the actual texture is returned. Yeah, okay, so if it can't pull the texture, that's why, yeah, I was having a problem earlier where objects were showing up black. So if the if the object can't be rendered, then this is the text object that it sets with. So it checks if it's valid. Real-time params. I don't know what the SC is for. Is valid. I'm guessing it's just to see if the scene is valid, maybe. And then if the text object is set, here's target size, text object get size, target VP equals text target get viewport, RT param. So target size, target VP, and then RT parameter. So this is an out, because you can see it's not set here. This is just an out. And then set the shaders. So I'm assuming it'll get right here, right there, and then it'll actually be setting the texture there. To return. And here you go. Kind of cool. Let's see what this is all about. Oh, because this right here, the GFX part actually calls a routine to get the pointer. So here's where the texture is actually set. To return. Or, sorry, I'm reading this logic. So I think this just checks to see if hold on. So it just returns if current texture.stage equals texture equals texture. Okay. So I'm not sure what the dirty state is all about. I'm not familiar with graphics processing terminology, and I'm assuming that's just a term to indicate that maybe a frame needs replacing or something. Texture stage, texture. Okay, so there's an overloaded operator here. It just calls the set with a texture object. So I'm assuming this right here is how things are being called, maybe? Step over, step. So this right here is overloaded. This right here is not. So this set, okay, hold on, go back. Set. Where are we now? Process shader material. Where are we? Process shader materials. Okay, I'm gonna try to get out. So set texture does a lot. It's not a small amount of code. Might wanna get into this a little bit more detailed. Step. Okay, return. Step. So this will just go over and over. Well, that time it didn't. Yeah, this requires a lot of stepping. Sorry. I think it's because of the threads and asynchronous processing. It's hitting breakpoints all over the place. Okay. Hold on, I'm gonna remove these breakpoints down here. I'll leave the ones in the texture object. Okay, so step over. There's a breakpoint in here. Step till return. Pull in a frame. Step till return. Back in text delegate. Step over. So if it's not playing, and that. Bitmap texture, refresh. So I think this is the majority of it. I'm gonna have to look in more detail and see exactly, like explicitly, like where the frame is generated, and kind of create a bitmap. Yeah. Okay. I'm gonna stop the video here. I'm getting kind of off on a tangent. But yeah, that's the second part of understanding this. Okay, let's